Hi, sixth grade. Today's goal in math is to determine the distance between points on a coordinate plane. Looking at the top of your worksheet on the right-hand side, it says if two sets of coordinates, which means 2 points, have the same y coordinate, they are on the same horizontal line. Horizontal means flat. So if you look at my example, I have 2 points, -6, 3, and 6, 3. You'll notice that the y coordinate is 3 in both. So I could pick any point along this line, -5, 3, -4, 3, -3, 3, 0, 3, and they are all on the same horizontal line because the y coordinate is the same. Similarly, if two sets of coordinates or 2 points have the same x coordinate, they're on the same vertical line. Vertical means that it goes straight up and down. So for example, I look at these 2 points, 4 and 3 and 4 and -2. The x coordinate for both is 4. So I could pick any point along this line and the x coordinate would be 4. 4, 2, 4, 1, 4, 0, and so it makes that straight vertical line. We're going to start off with the opening exercise. Read with me. 4 friends are touring on motorcycles. They come to an intersection of 2 roads. The road they are on continues straight, and the other is perpendicular to it. Perpendicular, let's go ahead and circle this word. Perpendicular means that it goes in an intersection or a plus sign pattern. So basically the roads are going to cross one another. The sign at the intersection shows the distances to several towns. Draw a map diagram of the roads and use it and the information on the sign to answer the following questions. So I have already drawn the coordinate plane for you. Notice that the scale is 1. So every hash mark that we get to is going to be 1 mile. So now we're going to plot our points. If I'm starting here at the origin, my intersection, and I'm going to Albertsville, I look up here and it says that I have to go left 8 miles. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to draw my dot on 8. And here it's actually -8 because it's left. And then above that, we're going to write A for Albertsville. We're going to do the same thing for Blossville. Again, I'm starting at my origin. This time I'm counting up. 1, 2, 3. Draw my point. And then next to it, I want to write E. Next, I'm going to Cheyenne. Cheyenne is 12 miles from my intersection. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I draw my dot. I write C for Cheyenne. Okay, last step, Dewey Falls. Go back to my origin, count over 6 miles. 1, 2, 3, 4, 5, 6. Draw my dot. Right, D for Dewey Falls. Now, we're ready to answer this question. What is the distance between Albertsville and Dewey Falls? So I'm looking at my A and my D. And here's what I can tell. Albertsville is, and I can look back up here to tell, 8 miles from my origin. So I'm going to say 8. But then, because that really covers this distance right here, that's 8 units. But Dewey Falls goes the other way from my origin, 6 units. So basically, I have to take my 8 and then I have to add 6. So I know that 8 plus 6 equals 14 mi for miles. Next part, what is the distance between Blossville and Cheyenne? I'm going to go back and look at my map. Blossville is at 3 miles north, and Cheyenne is at 12 miles north. So since those are both north, I can't add 3 and 12 because if I count the distance, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I'm actually doing here is I'm subtracting. I'm only counting this distance here, which either requires me to count my units like I did, or I can subtract. So I'm going to show my work here, and I'm going to go 12 minus 3 equals 9 miles. Last step. On the coordinate plane, what represents the intersection of the two roads? Just to double check, I'm going to look back here. I know that my intersection is at 0, 0, which has a special name. So I'm going to put both here. I'm going to say 0, 0, or the origin, because that is the name of the intersection of the x-axis and the y-axis. Okay, let's look at example 1. It says this. The distance between points on an axis. Consider the points -4, 0, and 5, 0. What do the ordered pairs have in common? And what does that mean about their location on the coordinate plane? I'm going to underline in common. I know in common basically means the same. So I'm looking at my two ordered pairs here, and this is what I can tell. The -4 and the 5, the x-coordinates are different. But the 0 and the 0 are the same, which means the y-coordinates are the same. So I'm going to explain that down here using words first. We're going to say their y-coordinates are the same. They are both on the x-axis, the same horizontal line. If I want, I can even plot my points up here just to prove it even further. So -4, 0, I'm going to start here at my origin. I'm going to go left to -4. 1, 2, 3, 4. I don't go up and down because my y-coordinate is at 0. So I'm just going to draw my dot there. Then I'm going to go back to my origin. My next point is 5, 0. 5 is positive, so I go right. 1, 2, 3, 4, 5. I don't go up and down because the y-coordinate is 0. So you'll notice here that we have the same horizontal or flat line between these 2 points. How do we find the distance between the two numbers on the number line? This one has a couple of rules. So I'm actually going to make my font a little bit smaller just to make sure I can fit everything in here. If they, the 2 points, are in the same quadrant, then we're going to subtract their absolute values, starting with the bigger absolute value. And I know that might sound confusing right now, but I promise it will make sense when we look at a couple of other examples. But what if they're in different quadrants? If they are in different quadrants, add their absolute values. Make this just a little bit smaller, so it's not getting in my way here. Okay, hopefully now you can see this. So, for example, if I look back up at these 2 points, notice how they're in different quadrants. They're on different sides of the y-axis. So to find their distance, I'm going to have to add both of their distances from 0. That's example right here. If they, or I'm sorry, that's the example here. If they're in different quadrants, we add. If they're in the same quadrant, we're subtracting, because that's exactly what we saw back here when we were looking at Blossville and Cheyenne. We had to subtract because they were both above the x-axis. Let's talk about the last step here. Use the same method to find the distance between -4, 0, and 5, 0. So I'm going to use my visual, and I know that they're in different quadrants, so I have to add their absolute values. So I'm going to say here different quadrants. Then I know that the absolute values of -4 plus the absolute value of 5 is going to give me my answer. Now I want to make sure that I write my absolute value symbols here. So we got to put those lines in. Absolute value of -4, absolute value of 5. So what is that going to equal? That is going to equal 4 plus 5, which equals 9. So my final answer here is going to be 9. And I can look up at the top and count just to be sure. So I have my 4 units plus my 5 units gives me 9. Example 2, the length of a line segment on an axis. Consider this line segment with endpoints 0, -6 and 0, -11 with a scale of 1. What do the ordered pairs of the endpoints have in common, and what does that mean about the line segment's location on the coordinate plane? So once again, I'm looking for what do they have in common, which means the same. So I'm noticing that they both have a 0 as their x coordinate. So we're going to start off our explanation with that. Their x coordinates are the same, but they are in two different. Did I skip a part here? I feel like I did. Sorry, their x coordinates are the same. They are both on the y-axis, which means that they're on the same vertical line. Find the length of the line segment described by finding the distance between its endpoints. Let's go ahead and plot our points on this line. So I have 0. I'm going to start at my x-axis and count down because it's -6. 1, 2, 3, 4, 5, 6. Then I'm going to count down to -11. So 6, 7, 8, 9, 10, 11. So here's my 11. Sorry, let's clean this up a little bit. We don't need this stuff. Okay, so there's my 2 points. This is what I'm noticing. -6 and -11 are in the same quadrant. So to find their distance, I can't add the absolute value of 6, or sorry, the absolute value of -6 and absolute value of -11. I have to subtract. And I'm going to end up counting 1, 2, 3, 4, 5. It's the difference between their points. So down here, let's go ahead and show our work. We're going to say the absolute value of -11 minus the absolute value of -6 equals, let's go ahead and add in our absolute value symbols. So draw your lines, absolute value of -11 minus absolute value of -6. So what is that going to equal? It's going to equal 11 minus 6, which equals 5. So that my final answer is 5. Okay, now let's go to example 3. The length of a horizontal or vertical line segment that does not lie on an axis. Consider the line segment with endpoints -3, 3 and -3, -5. What do the endpoints, which are represented by the ordered pairs, have in common? What does that tell us about the location of the line segment on the coordinate plane? So I'm noticing that they both have -3 for their x-axis coordinate. So we're going to say here, their x coordinates are the same, but I'm noticing that they are in different